Thank you, everyone, and welcome to this webinar of France Energy Marine that is named Challenges and Opportunities for the Offshore Renewable Energies. And I'm very proud and happy to have around the table today four of the members of our Scientific and Technological Committee that are actually reviewing our research project and wanting the excellence in terms of scientific content of the project. And I will be giving talks today. I will get back to that just later. So here are our panel today. So I will be giving a short tour of our scientific roadmap just after that. And we have then four top-level scientists from the finest institute in the world dealing with offshore renewable energies. Senus, researchers in mechanical engineers at NRL in the US. Salvatore Darco, Senior Research Scientist at SINTEF, Andrea Copping, Senior Researcher at the Pacific Northwest National Lab, and Torgern Wan, Professor at NTNU, the Norwegian University of Science and Technology. So as I said, I will be giving you a short presentation of our scientific and technology roadmap. Then there will be four talks. So the first one will be by Senus. We'll talk about R&D activities on the floating offshore wind technologies at NRL. Then we will have a presentation from Salvatore Darco on interoperability in offshore transmission, followed by Andrea Copping, who will tell us about using marine energy to support ocean observations, powering the blue economy. And Torgern Wan will end the meeting with a talk about assessment of marine operations in the offshore wind industry. So each of these talks will be about 20 minutes. Mine will be, I think, a bit shorter. And after each talk, there will be a question and answer sessions. So we invite you to ask your questions through the questions tool in the GoToMeeting window. If you see it, it should be on my screen. It's on the bottom, just next to the chat line. So please use it and ask any question you want to ask, and we will reply to it with the panel at the end of each presentation. Okay. So now we move on to the presentation of France Energy Marine Roadmap, this is a document that we review every 3 to 5 years, and that guides our research and development activities at France Energy Marine. It is organized around 4 main programs. The first one is a site characterization program. I will give a more detailed presentation of each program just after that. The second one is system design and monitoring. The first one is the farm optimization, and the fourth one is the environmental integration program. So now some detail about each program. So the first one in blue here is the site characterization program, where we are looking at facilitation of observations, which is very important because traditionally most of the measurements are done in situ with some buoys, for instance, for the waves, or some anemometer on buoys for the wind. And what we are trying to do is to get a better vision or description of the spatial variation of the resources and constraints of the environment. So we have actually developed some tools to work from to analyze satellite observations, but also to observe waves, for instance, remotely using stereo video systems here. And we are focusing on storm waves, which is one of the sub-axes of the program here, and breaking waves. And these storm waves, as you may know, are concerns, especially in the context of the climate change, where we expect that storms might be more intense or more frequent. And this is especially true for hurricanes. And so we are looking at this problem through the angle of the climate change as well. We'll be building projects on climate change, and climate change will change the extremes, but also change the average wind power. So we'll be looking at that, and we are working on improving the modeling of the wind as well, with the specificity of the wind blowing over the oceans and trying to address the interaction between the two, looking at the atmospheric turbulence for the design of the turbine, which is a major concern because we still don't know how to measure that at sea, where you need a buoy to deploy a LiDAR, for instance. And we are also addressing hydrosedimentary processes and with possible actions around the cable landing zone. This is an example of the cable landing zone for the Saint-Nazaire wind farm in France here. And the question of the resilience of the coastlines, especially again with regard to the effect of the climate change and the storms and the waves that drive the local hydrodynamics and morphodynamics here. So the second program deals with the technologies, and it's called system design and monitoring. So here we have different sub-axes. The first one is looking at the structure, the molding lines and electric cables. And we are actually looking at the coupling between the biofouling and different components such as power cables or molding lines that can be affected by biofouling. And this biofouling can change the mechanical properties and the drive, for instance, of the components in the flow. So here you have an example of inspections of biofouling around samples of power export cables and molding lines that is done in the frame of a project called Elements in Etel, in Brittany, in France. And we are actually trying to quantify the type and classify the type of biofouling that is growing and the effect on the structures. So the next is dealing with the free structure interactions and also what you need to know to correctly model with numerical tools the behavior of, for instance, floating offshore wind turbines. And these kind of tools are actually required to develop performing digital twins and in-service monitoring. And this is also a very strong axis for the future of Western Energy Marine. We'll be working a lot on digital twins. We already have an experiment on the former high wind demo in Norway, where we have deployed different sensors on the anchors, on the structures, to monitor the structures and try to understand how the edging is going using numerical models fed by in-situ observations. Okay. The third program is dealing with the environmental integration. Here we are looking at the effect of the offshore renewable energies on different compartments of the ecosystems. So we are looking on the effect of the fishes, regarding the changes in habitat. We are looking at the effect of different emissions, like electromagnetic emissions, sounds on marine mammals, for instance. Also, a lot of activities that will be coming on soon regarding the interaction between offshore winds and birds, which is a very important topic at Western Energy Marine. We are also trying to understand how different emissions from anodes can interfere with or change the behavior of different species. And we are also looking at the interaction between the offshore wind activities and the ecosystem, and the socio-economic world, such as the fishermen here, for instance. So basically, the first sub-axis here is looking as a zoom on the effect on the ecosystems. Then the second one is looking at a global, more global scales on the interaction between the ecosystems, the socio-economy, and the activities of the offshore wind or offshore renewable energies. And we are also trying to go one step further, looking at eco-conception, life cycle analysis, recycling of the material to improve the long-term integrations of the activities in the biologic and socio-economic world. So the fourth and last program deals with the farm optimizations. So there are three main sub-axes: farm architecture, where we are trying to optimize the wind farms, trying to minimize, for instance, the wake effect, but also minimize the number of anchors or mooring lines to reduce the cost of the energy. So here you have an example of two floating offshore wind turbines with mutualized anchor, and we were trying to understand what was the effect of having two mooring lines more on a single anchor on the fatigue and the soil near the anchor here. We are also looking at the integrations of the electricity coming from offshore wind farms, using and investigating the opportunity to have production of hydrogen, for instance, together with wind farms, and using different options of use for this hydrogen. And the third axis is dealing with the installation, operation, and maintenance. So I already mentioned that, but definitely this is a big challenge for the floating offshore wind, and a big source of innovation and optimization and cost reduction for this technology. So we have a big project running now called FILIPOT that is addressing basically all of the sub-items that you can see here.